Hello, so I'm Gavin Vashie, and my project is going to be microplastic contaminants in Indiana PA's freshwater systems. My research advisor is Dr. Katie Farnsworth. I'm within the geology department here at IUP. So my research. This work sets out to quantify the microplastics passing through the wastewater treatment facility and into the local streams. My goal is to measure the amount of plastic pollution that passes through Indiana, Pennsylvania's aquatic environment. My research involves the examination on the unseen pollution called microplastics. So here I just have a picture of a local stream here. It's right outside the Kovalchek Center. Right in front of it, at least. Okay, so microplastics are simply small broken down pieces of plastic debris in the environment caused by the breakdown of industrial water and consumer products. This can be anything from beauty products to everyday plastics such as like straws there, your water bottles and everything. And the same goes for the industrial waters. The use of plastics. Eventually it wears down like everything else, and then particles flake off and go to the water. So microplastics are dangerous from the chemicals that can absorb into the plastic particles over time, block digestive tracts, reduce growth and reproductive output. That was mainly found in aquatic life such as fish. So if we're doing that to the fish and then we're eating fish, that's not great as well because you're just getting more concentrated microplastic within your food source as well. And I'm sure it's not great for us as well. So the hypothesis of this study is the increase of the population of IUP's campus will lead to the increase of microplastic pollutants that will lead to the local water systems. The increase is believed to happen with the increase to the town's population during school. For the same reason, the waste and sewage increases and the students are coming back to the university. And then here's just another image I have. You can actually see the hotel right next to the basketball arena, or Kovalchek Center. So here's a study area. It's just Indiana PA's freshwater stream systems. The focal point of these contaminants will be focused to the Indiana Borough Regional Wastewater Treatment Facility, being the town's local sewage treatment plant. The streams of interest will be Stony Run and Tula Creek, which are kind of here. Can't really see them within my image here, but it's just an overview of the wastewater plant itself, where it just keeps on working down to where it's this more finer, cleaner water till eventually gets around here, gets held, and then eventually becomes effluent and gets released into the larger stream. So the importance of this study is that the unseen pollution within our environment can cause problems to our environment's health along with ours. Still is much unknown about the effects of microplastics to humans, along with the amount of present in Indiana. Microplastics are dangerous from the health hazards that I mentioned earlier that we found in aquatic life, and it certainly doesn't help us as well. So here's the collection. Effluent is collected with a stainless steel sampler, then placed into a 1 liter glass jar. I don't have the 1 liter glass jar, but it's just a mason jar. You avoid using a plastic lid. Oh, you can kind of see it right there now. I said that. So it's like an aluminum lid there with a glass jar. And then here's a stainless steel sampler. It's probably around 7, maybe 8 feet. And that's just to have Roland here that I've been working with go all the way down and reach that water. You ideally want to collect what's on top because it's just a lower... I'm sorry. It just floats there easier just because the plastic is less dense there along than the bottom, and it's also deeper down. So, I mean, it works out. So here's the procedure. The samples will be left in the refrigerator until processing to prevent the growth of bacteria. The 1 liter water will be taken to the sieve stack where the water will be recollected with another 1 liter glass jar, rinsing microplastics from the sieve and placed into an individual aluminum tray to be observed under a microscope. The container will be kept under aluminum foil to prevent microplastics in the room from contaminating the sample. Say like you're wearing some kind of synthetic clothes, the fibers will fall off that, and then you see that you have more samples than you actually do, because you're contaminating it. When the sample is dried and ready for analysis, the use of a stereoscopic microscope will be ideal, all being attached to a monitor to be able to capture images to be able to depict the findings. During the analysis, the use of software will be running to be able to measure the microplastics present. The software being used will be ImageJ to determine the longest length and area present of the present polymers. So we just go to the next. So the methodology. Current work has developed a protocol for sampling and separating out the microplastics. The effluent is processed through a set of stacked sieves, small as 64 microns, to separate the plastic and organic material. Hydrogen peroxide is used to remove the organics from the microplastics. Once the acid is added to the samples, it's put into a drying oven to evaporate the solution to leave the microplastics in the aluminum container, each separately organized by date, then size of sieve. Collection has started since March here of this year. Each of the samples will be quantified by the type of plastic. That's done by the size. Say it's a little ball opposed to like a fiber, to give you an example. So here is just me adding the acid, hydrogen peroxide to the water, and then this is what I use to spray the sieve out. I use this little squeeze container bottle, and I do it over these, and that's just by the sieve itself, so it's just two of them. And then there's the water sample itself, and then here's the oven, to where you put that in for about a day, and with the acid and water, it evaporates, and it just leaves the organics that are all like dried up and burnt looking. Could even be like a white color, but usually they have a bubble in them to where they don't look like they're plastic, because it still has like that plastic transparency look to them, even at the smallest size. So the results shown over time since March of this year that microplastics have been found within the samples collected. So I made a little data chart here. So with that, alright, and for that we have 2 for each month. So March we have 63 microns and 125 microns. Those are just the 2 sieve sacks, sieves within the sack. So we just have 2 and 4 of that month. For April, we have 3 and 4, and then May is going to be, 3 and 3. June, we have 6 and 8, and July is 5 and 4. I did a couple test runs with these as well. I took 2 samples for July just to have a little controlled area, and they're roughly showing the range within that. I did realize they're along the wall more often than they are just kind of in the center. That's practically it. I also want to show you these images, I guess. So right there is a little one. I think it'll show my cursor. And then with this, you can see the fiber a little bit. So originally I thought that was a hair, but then I wanted to test it, so I just got one of my hairs and just held it underneath there. You could definitely tell the difference. There's not the same textures. This is more smooth. It looks more like of a plastic, like if you pull a string off your shirt. It has that same look, just very small, micron sized. So the continuation of my research. In the future, I plan to expand this research to the surrounding streams around campus and possibly further, along with continuing the sampling from the wastewater plant to further monitor the number of plastics, along with the use of ImageJ to actually try to identify these plastics that I found, but I do keep everything here. And with that, I'm all done. Thank you, and if you have any questions, I'm pretty sure that I'll be answering it here soon.